who approach analyzing unstructured data uh, often find it initially difficult. I don't know if you experienced this, marrying it with some of the more conventional statistical thinking, which looks at numbers, for example. Did you ever have that challenge, or how would you advise people to navigate that? Because you're literally looking at like an unquantified data point or an unquantified data set, literally words and texts. And a lot of people get stuck with the idea of just counting text, which is probably where it initially starts. But now with large language models, it's obviously much more complex. So for people starting out in NLP and dealing with that kind of data, I mean, what's a good kind of thought process to follow before it, like in your case, you turned it into like trading signals or ways of helping people with in finance. I find
Yeah.
that a really interesting merger.
Yeah, I think that's right. I think in the past you would have had to count tokens. You would have to figure out like the frequency of certain tokens relative to the corpus, right? So using techniques that are still relevant but maybe not as commonly used. I think nowadays the easiest way to work with a lot of textual data is to convert them into embeddings, right? So converting the text into numerical vectors that you can then use to build classifiers from, or any decision-making model. So if you want to do sentiment analysis, you could create the classes for the different sentiment that you want, and then train a classifier, maybe using gradient boosting, right? So like a light GPM model. I think where I would start is there is so much incredible information on how to do NLP well, particularly modern NLP on the web. Certainly great books, but I think there's a lot of great blog posts and great hands-on examples on the web. We didn't have that 10 years ago, right? We didn't have that in some ways even 6, 7 years ago, even 5 years ago. It was still a little bit scarce. I think now there's just great tutorials that you could walk through. You can understand why did someone approach a problem in a particular way. And then what happens is that you develop that skill set. For me, when I was starting off, really getting deeper into NLP, I would love to look at Kaggle competitions and see how people solved the problems to win first, second, or third place in some of these competitions. And even though there are many ways to slice the problem, you could see that people approach in unique ways to get first, second, or third. And you learn about alternative approaches, maybe techniques that you haven't tried that you should try. But I think the best learning can come from hands-on learning, right? I think if you get too in the weeds and just do theoretical, the space changes too fast. And unless you're doing NLP research, you don't need you don't need to go super deep on the theory. You should develop some understanding so you develop intuition. But what's more valuable is the applied, the implementation, getting hands-on. So I'd start there, particularly if you're looking to be an NLP engineer that's applied, as opposed to an NLP researcher.
Yeah, it's a fair point. People usually come in two forms: people who learn by the book and are trying to apply stuff. And I take it you're more of the other type who learn by applying stuff, making mistakes, and then you're writing the books, which is awesome. Maybe can we shift a little bit into being an author? So what inspired you to write these books? And it seems like it doubles down on your background in NLP. So like the experience of being an author, and maybe there are other aspiring authors out there, some ideas that you can share with them.
Yes, absolutely. The first book that I wrote with O'Reilly came out of actually conversations where a book publisher that was non-O'Reilly reached out to me in late 2017 about unsupervised learning. And at the time, I was working deep on unsupervised learning for an Israeli startup called Theta Ray to find basically fraud, money laundering, any sort of like really bad actor items in large data sets, particularly for insurance and for banking. And when I saw that request come through, I realized that the reason why this publisher wanted to write on this topic was unsupervised learning wasn't really covered well, right? Supervised learning, using labeled data to build models, that was covered maybe like 90 to 10, right? So for every 9 of supervised, you might have something on unsupervised. It might even be more just lopsided than that. But the thing that I saw was that this topic wasn't well covered. And so I realized that this deserved to be covered. I was in a really great position to do so because I was working on unsupervised learning at the time. And then I said, well, if I'm going to write this book, who's the best publisher to get this book out with? And then I realized O'Reilly Media, is the biggest technical publisher in my mind, and one of the most reputable. And so I reached out to them saying, hey, I really know about this topic. I think it's underserved. I think a lot of people should know more about this topic than they do today. And I wrote the book in 2018. We published it in 2019. And I think actually this book continues to do very well because it is still to this day an area that a lot of people don't write about, right? Because supervised models people write a lot about, computer vision people write a lot about, even NLP people write a lot about, especially now. Unsupervised learning is still not that well covered. And then the second book I wrote came out of the success of the first book. So in 2019, I said, hey, book writing was really fun. I still have some time to go and do another book. So I said, NLP is super hot, right? Coming out of BERT in 2018. And so I for this one, got a co-author, started the writing process in 2020, and then published it in 2021. The challenge there, though, is NLP moves so fast. So basically, by the time I wrote it in 2021, a lot of the material there, while still relevant, it had changed, right? Large language models, GPT-3, and other LLMs really started taking hold to a point where a lot of that book, while it's still relevant, it's a little bit dated compared to where the large language model space is just 2 years later. And I imagine that there's going to be quick advances. So a year from now or a year and a half from now, there are going to be dramatically more advances versus today, where you will actually need an updated book even beyond that to continue to stay on top of the latest trends in NLP in particular.
Yeah, maybe I'll hit that button immediately because that's the hot button now. A lot of the work in large language models and even computer vision with the image generation tools really took a very, very different turn with the emergence of transformer architectures, diffusion architectures. So as an NLP practitioner, can you talk a little bit about that? Let's just open the hood. How do you think the thought process changed with the transformer, and how is it evolving now?
So I think the transformer architecture really came about in 2017 and then progressed in 2018. I think before then, you really had to work on like, I would say, handcrafted feature extraction, right? You had to basically you would convert text into embeddings, but you needed to build a lot of custom features that could then feed some NLP model to do what you wanted to do. And the other big challenge was that you couldn't work with long spans of text, right? And most of the NLP work at the time was like classification oriented or extraction oriented, like NER, named entity recognition. You couldn't do much more. You couldn't certainly generate 2 sentences even at the time. So generation wasn't really common. It didn't understand semantic context well, right? So semantic context became more of a thing once BERT came about in 2018. So I think transformer architecture allowed there to be greater semantic capture from the model. The model could attend to relevant portions of the text better because of attention mechanisms, which really are the backbone of the transformer architecture. And then you had basically a lot of knowledge that was acquired. So you had pre-trained language models for the first time. Before that, you really didn't have what I would consider pre-trained language models. And so BERT really changed things, right? The embeddings that you had semantic context. It could handle spans better than the past, and they were pre-trained, so you could do fine-tuning on a smaller corpus because pre-training was done on a larger corpus. So Google made it easier to work on downstream tasks which required less fine-tuning than they did before. I think with OpenAI's work on GPT-2 and then GPT-3 and then now GPT-4 as well, you could get zero-shot or few-shot learning done, and that was not possible at all in 2018. 2018, you still needed thousands of examples to build a good model, fine-tuned model. Now, you could do few-shot or even zero-shot learning and get really great results. Now, of course, if you have hundreds or thousands of examples, you get mind-blowing results, right? And that's something that we do at Multimodal. We do pre-training, we do fine-tuning for our customers in specific domains, and the performance is an order of magnitude better in many ways than what could have been possible pre-modern LLMs, right? Modern large language models. But the transformer architecture really changed things coming out in 2018.